So everyone see this particular thing, whenever you have an AC connected across a capacitor, then what will happen? This EMF will make a certain current flow through the circuit. Due to the current, the capacitor will get charged. The instantaneous charge on the capacitor is, let's say, Q. So we try to find out what is Q. Q is equals to C into E. E ko we wrote it as E naught sin omega t. So Q equals to C naught sin omega t. Q equals to Q naught sin omega t. Well, what is Q naught? Q naught is basically the maximum charge stored on the capacitor, right? After that, we wanted to find out what is the current in the circuit. So we differentiated this equation. When you differentiate Q naught sin omega t, it will come cos omega t. So when you differentiate charge, you get current I equals to I naught cos omega t, which we can write using trigonometry formula I equals to I naught sin omega t plus pi by 2, right? So note करने वाली बात is this कि whenever we have a EMF which is sin omega t, then charge and EMF, they are in the same phase. Can you see omega t and omega t same phase? But when we talk about the current is not in the same phase. The current is pi by 2 ahead of EMF. Can you see it is plus pi by 2, right? Yes or no, guys? So when we try to compare it, can you see sine, sine, sine? Here it was omega t, the same phase. But here it was omega t plus pi by 2. So this, I told you, this thing is called as the phase, right? So the phase of current is basically pi by 2 ahead of basically what? EMF and charge. Is this clear? So from all these equations, we can say that when a capacitor is connected across an AC, then the potential difference across the capacitor is, can you see, potential difference across the capacitor is lagging behind current by a phase difference of, can you see, the phase of current was basically omega t plus pi by 2, and the phase of EMF was basically what? Potential difference was basically how much? Omega t. So if you subtract both of them, can you see pi by 2 you'll get? So the potential difference is basically lagging behind current by phase difference of pi by 2, or you can say the current is leading the potential difference across capacitor by a phase difference of, so it's up to you. And I try to remember it like this. Okay, I never try to which is lagging, which is, I always try to remember in the name of current. In the case of capacitor, the current is leading. And how will we remember this? Capacitor, then current leading. Is this clear? अच्छा, what? हाँ, बोलो. अच्छा, tell me, guys. If by chance, if the current is given I equals to I naught sin omega t, so can anyone tell me this particular thing? What will be the value of EMF if current is given sin omega t? Earlier, what was given sin omega t? EMF was given sin omega t. Now, current I am giving you as sin omega t. Then what shall be the phase of this EMF when it is connected across a capacitor?
Omega t minus pi
by 2 minus
exactly. Now you understood it, no? It will be omega t minus pi by 2. Why it will be minus pi by 2? Can you see? I told you, no, current is pi by 2 phase ahead of EMF. So if current is omega t, then you have to subtract the phase by pi by 2. Okay? The reason you will understand after a while. Once I'll teach you phasor diagram now, the user, the reasons also you will understand. Is this clear? Shall I draw a
Yes.
diagram? Guys, shall I draw a diagram?
Yes, sir.
So let me diagram will be thoda sa big. So on the y-axis, basically I'll plot what? On the y-axis I'll plot whatever the current is there or EMF is there, and on the x-axis I'll plot time. Okay, I'll try to do it for one cycle, but ठीक है. थोड़ा सा graph will become complicated. Does anyone know how to draw this thing, dotted line in the case of this? Anyone? Guys, I'll draw the graph of current and EMF with different color. For now I'm just preparing a graph, है ना? This is basically the maximum value of let's say EMF, and this is the minimum value of EMF. Similarly, this is the maximum value of, let's say, current, and this is the, sorry, minimum value. For now I'm just drawing the graph. Abhi, that curve will draw later with different colors. Okay, different time intervals I'll give you. You need to draw the graph exactly just like I'm trying to do. T by 4, T by 2, and you can use a scale pencil, guys. मेरे पास नहीं है. I don't have the privilege. You have it, so please draw it accordingly. So basically I'm trying to draw for two different cycles. Okay, I'm trying to draw two cycles so that it will be much more clear to you. And let this. Okay, now after this, let me draw the EMF. Do you remember, guys, what was the equation for EMF? E was equals to E naught sine omega t, right? So I'll draw the graph for sine omega t.
So 2 times 3t by 2 is written.
Okay, 3t by 4, 0.75, 0.25, 0.5, 0.751, 1.25, 1.5, 1.75, 2. It's like this. Okay,
Yes, sir.
so guys, can you see this particular thing? The first graph which I have drawn is for EMF, the red one. And can you see it is just following the normal sine omega t curve follows, right? Yes or no? Is this clear?
Yes, sir.
Now, what if, what for the current? Do you remember the current was basically what? Cos omega t. Come here. Come here, come here. Here. The current was basically cos omega t, and we know the graph of cos omega t is like this, right? So I'll draw it for current as well. See very carefully, guys. Very carefully. This point, 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 and this point has to be joined. In the case of EMF, very carefully this, 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 this. Hmm? So guys, can you see both the graphs? Is the graph clear, guys? What information can you gather from the graphs? Anyone?
This I is lagging by pi by 2.
हाँ जी. Hey, sorry. Oh. Omega t plus pi by 2. Current is leading by pi by 2, no? Yes or no? Another current was leading by pi by 2. Plus pi. Where does the plus go? अभी तो बनाया. Plus pi by 2. Okay. Is this clear, guys? Acha, please remember, whenever there is a phase difference of pi by 2, that implies by a quarter cycle, right? Yes or no? And everyone can see. Acha, once you're done the diagram, guys, please tell me. We'll explain you some points regarding how to read it directly from the graph. Hai? Just by seeing the graph, you will understand ki, acha, this is the capacitor and this is the inductor. डायग्राम को मेक इट वेरी केयरफुली, है ना? Guys, are you done?
Yes, sir.
अब देखो, how to identify directly कि whether this is the graph of capacitor or how to read this graph. Simple. First of all, first thing you need to keep in mind. Tell me this particular thing. If you, let's say you start from 0, time t equals to 0. Tell me which will come first. Will 2t come first or 3t by 2 come first? Suppose if you are running in time and I am telling you to reach two different time instants, one is 3t by 2 and one is 2t, then which instant will come first?
3t by 2.
3t by 2.
सबको पता है कि 3t by 2 पहले आता है, right? So you will reach 3t by 2 quickly, है ना? Now suppose you are the person who are running in time and you are either EMF or current. Okay?
Okay.
है ना? Understand this very carefully. Suppose you are either EMF or you are either current. Now can you see this particular thing? Out of EMF and इधर नहीं, इधर देखते हैं, यहाँ पर ये see after time t, okay? Or see after time 3t by 4. Tell me, out of EMF and current, which will reach the maximum value first? Will current reach the maximum value first or will EMF reach the maximum value first?
EMF.
Current.
Now why is there difference in opinion? Why current? Someone is saying current and someone is saying, can you see the current reaches the maximum value at time t, right? Whereas the EMF reaches the maximum value by at 5t by 4. तो कौन पहले पहुंचा?
Okay, then current.
Are you getting my point? So if
Yes,
current is अब मेरे को एक बात बताओ, are both of them running faster or slower कि both of them run at the same speed? Is the omega same for both of them?
Yeah. Yes, sir.
So if the omega is same for both of them, that implies current and EMF both are running at the same speed. Okay. But can you see current had a head start of how much? Of pi by 2. Current had a head start of pi by 2, due to which what happened? It reached its maximum value earlier as compared to EMF. Are you getting my point? So always try to go whenever you need to mention this thing, no, just look at the maximum value. किसकी पहले आ रही है? So can you see? You can see clearly in this graph that the current is reaching the maximum value first, and then the EMF is reaching after some time.
Yes, sir.
Current reaching its maximum value at either t equals to 0 or t equals to t or t equals to 2t and so on, whereas EMF or EMF की जगह पे we can write whereas the potential difference across capacitor reaches its maximum value at t equals to t by 4, t equals to 5t by 4, t equals to 9t by 4, right? And so on. Yes or no? So by this observation, what do we mean? What do we get? That current
Leading by a phase difference.
or you can say कि current is ahead. Can you see current time से इसके time से पहले ही हो जा रहा है, तो current is ahead of the potential difference. Is this clear? So this is how you can understand it graphically. It's not necessary कि you need to go at this. You can understand from here only. Can you see t equals to 0, t equals to t by 4? So the EMF is reaching later, current has already reached. That implies the current is running faster or current is moving ahead. Is this clear? So understood graphically, how do we do it? This is one of the approach.
Yes, sir.
The second approach, what I used to do is basically this. If suppose this is the graph, no, I used to produce this graph in the backward direction. So when I produce this graph in the backward direction, now everyone can see clearly that current started earlier. Can you see current started at a at a negative time when we not even started observing, right? We started observing at t equals to 0. So the current, if I draw the graph in the backward direction, now can you see both the graphs are starting from the same position, the mean position, right? But can you see current is starting ahead of time? मतलब वो गोली चलने से before the gun is shot in the air, current started running. Are you getting my point, guys? So this is also one of the method which this is again a trick. So to read these graphs, and this trick will help you in many places. Alternating current, simple harmonic motion. There also you will have the graphs, right? Enough. So I think if this is clear, guys. Everyone understood this particular thing. In the case of capacitor, current is leading, right?
Yes, sir. Sir, I had a doubt.
पूछो.
What's the physical significance of this? Like, why does this only happen in a capacitor?
Why does this only happens in a capacitor? Because see, when you try to क्या बोलते हैं करंट की बात करते हैं. अब मुझे एक बात बता कि सपोज इनिशियली when the current will start flowing, then your capacitor will get charged.
Yeah.
ऐसा होता है कि current, when it is not flowing, the capacitor charge is increasing, current is also increasing. No, it does not happen like that, right? So basically what happens when the current starts flowing, the charge on the capacitor keeps on rising, due to which the current keeps on decreasing. आया ना? Or capacitor, may we know this particular thing. Once the capacitor is fully charged, the current becomes 0.
Yeah.
So can we say this particular thing कि current and charge will never flow in the same phase when a capacitor is connected?
Yeah.
And एक जब maximum होगा तब दूसरा 0 होगा. So that's why there was this difference of this quarter cycle. जो कि pi by 2 के phase में we have written it.
Okay. Fine. And so in resistors, how do we explain this in resistors?
Resistors, there is nothing which can do like this. Resistor, everything is current only. No role of charge, no role of rate of current. Everything is current only. तो वहाँ पर current flow होगा तो resistance में heat produce होगी.
तो वहाँ पर voltage leads by pi by 2, right?
नहीं, in the case of resistance, the current and the potential difference across resistor are in the same phase. No आगे पीछे.
Okay, fine.
And here current becomes leading, right? Now in the next case, what will happen? Acha, before that, do you remember I talked to you about this particular thing? We wrote I naught is basically equals to E naught divided by 1 upon omega c, right? Yes or no, guys? This 1 upon omega c is denoted by xc. So I can write this thing as E naught upon xc. You can write this. Here xc is equals to 1 upon omega into c. Xc is called as the capacitive reactance of the capacitor, or either you can say capacitive reactance or you can say it's the reactance of the capacitor.
So what does reactance mean exactly?
मैं वो भी समझाऊंगा. What is this word reactance? Okay. Now let's first define what exactly is the reactance. Reactance is basically the effective resistance offered by an inductor or a capacitor. Please remember if it will be the next term after this we'll be discussing is XL. So XL is basically the inductive reactance. Okay. I'm trying to explain you generally what exactly is this reactance. So reactance is basically the effective resistance offered by an inductor or a capacitor when connected in an AC. So basically, what is basically this property of reactance? See, our capacitor and our inductor, basically they are designed to operate for direct current, right? Yes or no? So basically, our resistor is very simple kind of guy. It doesn't matter. It doesn't care whether I am connected to a DC or AC, because it has to lose power. It is just interested in paisa udane ke kaam mein, right?
Yeah.
So basically, suppose there is this guy in a family is basically interested only in spending money. So whether it doesn't not matter whether the money is coming from papa or whether the money is coming from mommy. He is only interested in spending that money to roaming here and there, spending at the malls, girlfriends pe kharcha, right? So basically our resistance is like that, but our capacitance and inductance are ghar ka bada beta. So basically they have they have a mentality to store some money let me save a little bit for a while. Are you getting my point? They are energy storing devices. Everyone knows this, right? Capacitor stores energy in the form of electrical energy, and inductor stores it in the form of magnetic energy. एक stocks में invest कर देता है, एक real estate में कर रहा है, but both are saving money, right? Hello.
Yes, sir.
Yes,
Now,
sir.
what happens when suddenly papa and mummy both start giving money to capacitance, the inductor and capacitance? Resistor was okay with both giving money, right? But capacitor and inductor, they are not okay. And by the way, papa and mummy, I means what? Basically one time the positive side current and one time the negative side current. Okay.
Oh, okay.
So capacitor and inductor are not okay because they have a certain polarity. So basically once one side current will flow, then what will happen? They will get energy stored in that particular direction. But when the current flows in the reverse direction, first they have to reduce that energy to zero, and then they need to charge again in the negative direction, right? So basically what happens, this capacitor and inductor, they don't like AC circuit connected over it. So they try to oppose it somehow. And how will they oppose it? By offering certain resistance, but they are not a resistor. They don't have a property of resisting, right?
Yeah, they don't.
So that is why we have to define a new tarika. This is how they will react, and that's why that is the reactance.
So you mentioned that capacitor has to make its energy zero. What do you mean by that?
For example, suppose in the positive 1/4 cycle, the current becomes 0 to maximum. At that particular instant, what will happen? The capacitor, suppose at one particular instant, the current becomes maximum to 0. That is the first half cycle, right?
Yeah.
I'll go to the graph again. And you see in the first quarter cycle, the current goes from maximum to 0. At this instant of time, our capacitor was getting charged, right? So at this particular time, our capacitor got charged. When the current became 0, the capacitor got charged to maximum. But now suddenly what happened? The current started
to be discharged.
Current, reversed its direction. So when the current reversed its direction, now the energy, or basically the charge stored on the capacitor plate, started decreasing. So can you see when the current became maximum in the negative direction, the charge and the EMF both decreased to 0. At one particular, now what will happen? The current will start decreasing in the negative value. So basically what will happen now? Now the charge will increase, but in the negative direction. And
so can I think of it like this? Ki पहले जब करंट फ्लो करा था तो वो एक प्लेट से दूसरे प्लेट पे इलेक्ट्रॉन्स लेके डाल रहा था, एंड जब हम रिवर्स कर देते तो जहाँ पे वो डाल रहा था वहां से इलेक्ट्रॉन्स
लेना स्टार्ट
निकालने
कर
लग
देगा.
जाते.
Yeah, it
ठीक
will
है.
start taking the electron from that plate.
Fine.
So everybody, now you understood what is the physical significance of this reactance. They cannot resist, right? Capacitor and inductor, they are not resistors, so they don't have any resistance, but still they were trying to resist somehow. So that's why we introduced the new quantity which is called as reactance. Reactance is basically what? It is resistance only, but offered by capacitor and inductor. But due to technicalities in the definition, we cannot define them as resistance. So that is why we have to introduce a new physical quantity which is called as reactance. Is this clear? Here this XC is called as the capacitive reactance. It's basically what? It's the effective resistance offered by the capacitor. XC is basically what? The capacitive, I have already written it. And I have already written what is XC, which is equals to 1 by omega C. And everyone knows omega is basically what? 2 pi F into, so I can modify the formula. Anyways. Acha, one note you need to write in this particular thing. The SI unit of a reactance is same as resistance. That is, whether it is capacitive reactance or whether it is inductive reactance, both will be measured XC or XL, SI unit. Both will be basically what? Ohm. The same ohm for resistance which we use, right? Okay. Is this clear, guys?
Yes, sir.
Yes, sir.
Acha, can anyone tell me what will happen if you connect? See, we know the property of a capacitor, right? When it is connected in DC circuit. So for DC circuit, can anyone tell me what happens when you connect a capacitor in a DC circuit? Does it let current to flow? In a DC circuit, does current flow? It's just only the battery, the capacitor gets charged to the maximum potential, right? It's just like that. So for DC circuit, we know that particular thing, that current is zero, right?
Like, so the current cases that we were doing for the capacitor, that was in a DC circuit, right?
The fixable.
जो अभी तक हम सीख रहे थे capacitor की theory, वो सब DC circuit पे
Yes,
था ना?
in that we never talked about the current, right? Because we know the current is zero, current instantaneously बढ़ेगा, and due to which all the capacitor will get charged, right?
उसके बाद it will decrease, the current will eventually be zero to infinity.
So initially अपन बोल सकते हैं, initially the current was maximum, but eventually after everything gets charged, when capacitor gets charged at steady state, gets completely charged, can I say the current in the whole circuit becomes zero? Now we know this property, right? We can explain with the help of XC as well. Now can anyone tell me for DC circuit what is the frequency? In the case of DC circuit, what is the frequency? Does it oscillate?
No.
The frequency is zero.
Zero.
If frequency is zero, then omega is
zero.
If omega is zero, then what is XC?
It's infinite.
Infinity.
So basically, can you see the capacitive reactance of a capacitor in a DC circuit is basically what? Infinite. That implies it will, it will offer infinite resistance, right? And if it offers infinite resistance, will it let any current to flow? Anna? So see, with the help of
So
this
this is the
concept,
reason why it blocks DC current.
because the charges, they don't, we know this particular thing, whenever we have a capacitor, in the case till the time the electric field is increasing between the plates, till that time we say a current is flowing. Once the plate goes to the maximum, once the capacitor gets charged completely, there is no further increase in charge or not, right? Charge becomes constant, so current becomes zero. I is equals to dq by dt. I know. Is this clear?
Wait, so I don't get it. अगर DC में काम करता ही नहीं है, then how did we do those previous cases? Then we have to take into account the effects that AC currents have on capacitors.
Feasible.
like जो भी तक हमने cases किए हैं.
We did all the cases which were on DC circuit. I'm talking
Yeah.
about pure capacitive circuits. Pure.
Okay.
I'm not
Oh,
talking
right,
about
right.
RC circuit, series.
RC circuits. Okay, fine. My bad.
So
Hmm.
in AC it forwards, it gives a reactance, right?
Yes,
So
it
does
reacts.
simple capacitive circuit also behave like a RC circuit?
नहीं, once more, फिर से once more.
It's giving a resistance to the system, right?
Mm-hmm.
So doesn't
Simple
that
capacitive
add
circuit does not become RC circuit. Simple capacitive circuit behaves as a pure resistive circuit. ऐसा बोल. In an AC,
no, in AC current. Yeah.
in AC current, a pure capacitor behaves as a pure resistor, reacts as a pure resistor.
Okay.
Okay, it does not react as an RC circuit. It reacts as a pure resistor. I'm getting my point. मतलब I'll tell you जब मैं numericals करवाऊंगा ना तो I'll explain you what exactly I mean by this. चलो. So I think this is pretty much clear to everyone. Everyone understood this particular thing. कि current leads by how much? Current leads by how much?
Pi by 2.
Very good. Now last is basically what AC across inductor. And now let's talk about AC across an inductor. Now I have an inductor. And let's say I have connected across AC source. So I is equals to E naught into sin omega t, right? Yes or no? Oh, my bad. E is equals to E naught into sin omega t, right? Hello? Hello?
Yes, sir.
So tell me this particular thing, guys. If you apply an EMF across this particular thing, then if I say a current I is flowing through this particular thing, if a current I is flowing, let's say the current is increasing. If the current is increasing, then this end will try to behave it like this to oppose the flow in current, right? We already discussed about inductor and these properties in the electromagnetic induction chapter. Yes. Can I say here in the case of an inductor, whatever EMF which will be generated, will it be equal to the instantaneous EMF? Because can you see this is only the source from where you are applying the EMF, and whatever EMF is applied, accordingly di by dt will be there, right? So can I say in this particular thing, the whole EMF of the source, just like in the previous cases, the whole EMF of the source was across the inductor, right? So the whole EMF of the source is across the inductor. In the previous case, the whole EMF was across the capacitor, and in the first case, the whole EMF was across the resistor, right? Here also, what will happen? So can I say this particular thing? L into L into di by dt, will it be equals to E naught sin omega t? Or will it be equals to E? The EMF across, this is the EMF across this thing, will be equals to the EMF across the battery, right?
Yes.
Can I say, if this is the case, then can I say this will be E naught sin omega t is equals to L di, and I'll multiply this dt over here. Is it fine? Acha, what is L, by the way? L is the inductance, self-inductance. Now what to do? Guys, now what to do? Integrate. So L is a constant, it will come out of the integration di, and this will be equals to E naught will be out, right? And what is the integration of sin omega t? Will do with the integration in the next step. Yes, can anyone tell me what is the integration of sin omega t?
Minus
Cos omega
Cos omega t. So can I minus cos omega t? So minus of E naught into cos omega t divided by omega. Last में can I write plus c? Since I have not put limits over here, can I write plus c? Right? So this LDI, this will become equals to L into I, right? And I can just give this L to this side. So can I write L is equals to minus of E naught by omega L cos omega t and plus this constant C. Please remember, this will be some other constant. When you will divide by L again, you are making a new constant only, right? Constant divided by constant. A constant C divided by L will be another constant, right? Since this constant is arbitrary, I can take any value, and this will be the value of what? The current, right? So I is equals to minus of E naught omega L cos omega t plus T. Now, see very carefully what exactly I am telling you. This constant of integration, the constant of integration over here, this C key value is basically equal to 0. You can write the reason, and I'll give you the proof as well. For any kind of alternating current, the value of I average is equals to 0, right? Over one cycle. Yes or no? Over one cycle, the value of I average is 0. Ayana?
Yes, sir.
Yes, sir.
So this constant is ultimately equal to this only. So ultimately C becomes 0. I'll give you the proof as well. For C equals to 0, proof. We know that I average is equals to what? Although please remember, this is not part of the derivation, hai na? You'll just write this statement if it comes in your school exam. You'll just write the derivation and that's it. I dt from 0 to t and it 1 by t minus 0. Can I write it like this? Guys, can I write it like this?
Yes, sir.
I average is basically 1 by t minus 0, 0 to t I dt. This is how we did the average value, right? Can I put the value of I dt over here? So 1 upon t integration of minus of E naught omega L cos omega t plus C from where to where? 0 to t, right? Yes or no? Yes or no, guys?
Yes, sir.
So basically what will be this? This will be 1 by t will be equals to, and this will minus of E naught, this will become cos omega t will become sin omega t, right? And one more omega will come in the denominator, so E naught minus omega square L sin omega t, and the limits will be from, oh sorry, there is a C as well, no? So plus ct, limits will be from 0. And I say this constant into dt, the C into t, and from limit is from this and this. So I can write this thing as 1 by t. Acha. Do you remember this thing? When you will put this limit over here, this value will come 0. This will go 0 minus 0, right? Sin omega t ko we are putting the limits 0 and 0. Yes or no, guys?
Yes, sir.
एक second though. This bracket shall not come over here. Please remember, guys, this E naught into minus omega square L, अरे ये पहला वाला, this term is only in multiplication with cos omega t, है ना? So when you integrate it, this term only comes with sin omega t. Ct will remain as it is. This E naught omega square is not multiplicated with this. So ध्यान रखना. Which function I am integrating, guys? I am integrating this function which we have obtained in equation number 1. I am integrating this function over a whole cycle, right? And can you see over here, when you will integrate it, this will be minus of E naught omega square L sine of omega t plus C into t minus of E naught omega square L sine of 2 pi by t into 0 plus ct plus c into 0, right? Are yes or no, guys?
Yes, sir.
So why
Basically,
C
I'm
into 0?
putting the limits. Yes, tell me.
Why C into 0?
Because at the place of t, I have put 0. I have put the limits over here, guys.
Okay.
So now
Oh, you
this
separately substitute.
separately substitute t and then separately substitute 0 and then subtracted it. This will be 0 because sine, can you see over here, sine 2 pi, sine 360 degrees 0. This will be 0 because it is multiplied by 0, and this will also be 0 because it is also 0, right? So what is the only term which will remain? Is basically ct, right? So can you see the last thing is basically 1 by t into ct, t and t will get cancelled and this will be equals to c. So what did we prove with this particular thing? That I average for that function is basically equals to that constant of integration. Yes or no? We understood this particular thing, that I average is equals to constant of integration, and we know this thing for one complete cycle, for one full cycle, I average value is 0. So hence proof. Okay. So from here, guys, you understood that C's value will be 0. In your school derivation, you need to write this particular thing. For any kind of sinusoidal AC, no, for any kind of sinusoidal AC, I average is 0 for one cycle, and here for this function, I C which is calculating C is equals to I average. So by both the things, please remember this proof is not there in your school syllabus, just this statement is there. So this constant of integration is 0. You'll write the reason for any kind of sinusoidal AC. This I average value is 0, and here in this case this constant of integration is equals to I average. So ultimately from both the comments, C's value is 0. Then if C's value is 0, then by equation number 1, can I write I will be equals to minus of E naught by omega L into cos omega t? Can I write this thing? This will be my current. Hi Anna. Hello guys, will this be my current?
Yeah.
So can I write it as, let's say I naught is basically equals to what? E naught upon omega L. E naught upon omega L. I'll later on term this omega L as something. I know. And can you see, I can write this I is equals to minus of I naught into cos omega t. But do I want minus sign? I don't want in the sign, in the form of cos, right? How do I convert minus cos into sine? Can you tell me a place where I want to, if I do sine of omega t plus or minus something, it shall give me negative. It can't be in the second quadrant, obviously, because if it will be in the second quadrant, then omega t plus 90, and this thing will come positive. I don't want this. So basically, if I want to convert cos to sine, so can you see in the fourth quadrant this will be that, or can I write this thing as, in spite of, can I write this thing as I equals to I naught sine of omega t minus pi by 2? Sir, why did we write minus pi by 2? Because can you see omega t minus pi by 2 comes in the fourth quadrant, right? And in the fourth quadrant, sine is negative. So that's why we have to do this. Is this clear? So we can write I equals to I naught sine omega t minus pi by 2. Is this clear? Please note this particular thing. In the case of an inductor of a pure inductor across an alternating current source, the potential or the current ऐसे लिख लूं, current will lag behind the potential difference across the inductor by a phase of please remember this particular thing. E was basically E naught sine omega t and I was basically I naught sine omega t minus pi by. Is this clear? Is this clear, guys? Can you see clearly over here the current is lagging now?
Yes,
In the
sir.
case of capacitor, the current was leading, but in the case of inductor, you know what happened? It started lagging. Is it clear?
Yes, sir.
So if I try to draw the graph, अब आएगा मजा. देखो, what I'll do and what you need to do. लॉल हो जाएगा तुम्हारे साथ. Control C and then Control. अरे बोलो, Control
F.
at B.
Copy paste.
Control F
V.
से होता है. Control F से होता है. I know a little bit. Control F से तो नहीं होता at least, है ना? And what will be
It's
the
Control
only
V, I
difference?
think.
What will be the only difference? Oh, so the only change is basically this. The EMF will remain as it is. Are yes or no? The EMF will remain as it is, right? People.
Yes, sir.
So please draw the same diagram again. I know it will be again a task for you people, but can you see what is the only change which we are doing? This is it. Can you see E equals to E naught sine omega t is same? Everyone can see this. E equals to E naught sine omega t is same. The only change will be I will be equals to minus of I naught into cos omega t, or basically sine of omega t minus 90 degree. So basically we know, acha, what is, how do you draw the graph of minus of cos omega t? Can you see whatever graph was for there for cos, no, you just reverse it. So initially the graph was starting from plus I naught, now it will start from minus I naught. It will go up, it will go maximum up, it will come down, then go up, come down. So यहाँ से graph will go like this. then it will go like this, then it will go like this, and then it will go like this. Can you see, guys, the difference? Only difference between the two cases is basically the direction of current is just the opposite. Current is flowing exactly the opposite how it was flowing in the previous case. Draw this and give me 2 minutes, I'll be back. Yes, guys, done? Guys, are you done? People, are you done?
Yes, sir.
So we understood this particular thing. When the EMF is this, and if it's an inductor, pure inductor connected, then the current will lag by a phase difference of pi by 2. How did I remember both the cases? Just remember कि capacitor, inductor. In C and I, which comes first? Alphabetically.
C.
And I always remember, I told you to always remember with the respect of current, right? Anna? We always remember with the help of current, right? So out of capacitor and inductor, in which the current will come first?
Capacitor.
First. So this is how I have remembered it. Anna? Either current comes first or leads. Okay. Is this clear, guys? This is this is how I have remembered. It's up to you. You can develop your own tricks and trick to solve this. And if you come with a better trick than this, then always reach out to me, sir. I have came out with this. So, batao, is this better than yours? If it will be better than yours, then I'll include it in my notes next time. Also, this trick was given to me by one of my students. So this is how I have remembered it now. Are you getting my point?
Yes, sir.
So please be always be open to discussions and all. Anyways, so I think this is clear, right? The diagram is also clear. This is also clear. Here, do you remember I naught was equals to what the maximum value of current was equals to E naught by omega L. Here I can denote this omega L by another term which is called as XL. XL is basically equals to omega into L,
Inductive reactance.
and omega XL is basically called as inductive reactance. This is how the inductor will react when connected across a AC source. So inductor is basically the effective resistance offered by an inductor to AC source. Is this clear, guys? So I told you कि our resistor is just like a खर्चीला लड़का. So he'll spend whether the current will flow, whether current will be coming from one side or another side, no matter, does not depend upon that, and it will always put off. Whereas XL and XC, this capacitor and inductor both are like the big brothers, the elder sibling. So they will save a little bit. They always save a little bit, so that's why they will show a resistance in spending the energy, right? So that's why. So I think I'm pretty much clear to again the SI unit for reactance. This will be also again same. SI unit will be again what? Ohm only. Okay. Acha. For DC circuit, does anyone remember DC circuit what happens? For a DC circuit, what was happening?
Omega is 0.
Frequency is 0, that implies omega is 0, that implies XL is also 0, right? So can you see in the DC circuit it was not opposing like that. It was opposing when the current was changing. Was it offering any resistance when the current was constant? People? No, right?
Repeat that.
At t equals to 0 in the case of inductor, in the case of DC circuits, anyone remember this thing? That when the current, the time was 0, at that instant the current started beginning, right? So the rate of changes was maximum, but the current was 0, right? So if the current was 0, then initially it did not oppose anything, but when the current starts rising, when the current starts changing, then the opposition started, right? So if I have DC current which is not changing, all of this is at steady state, na? At t tending to infinity, steady state. The current becomes constant here, and if the current becomes constant, that implies the rate of change of his current is 0, and here inductor does not play any role. So can you see with the help of DC, you can analyze with the help of this as well. For DC circuit, the frequency is 0, omega is 0, then this is 0. If the current is not changing, that implies the resistance, this inductor will not oppose anything. Clear? So with this thing, I'm done with the 3 main things. In the next class, I'll connect all of them in series, parallel. generally in series, because parallel is easy. I'll tell you how to deal with this parallel connection. We'll see the RLC series circuit, all three of them combined together. But before that, we'll discuss phasor diagrams. Enough. So in the next class, I will be seeing phasor diagrams, and clear.
Sir, so for inductors and capacitors in DC circuits, we see the same case like happening.
Yeah, we see the same case, but that can be explained with the help of the knowledge of AC.
Yeah.
Sorry. So that's it, guys. Thank you very much. We'll see you again.
Thank you, sir.
Okay.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Okay, बच्चों.
Thank you, sir.